So this is just a little kind of like review of alkanes, alkenes, and alkynes, just to make sure that we're on the right track. So this first one, I'm asking you to name it and tell me where this group is. So tell me the number that it would get. So you may want to pause the video here if you haven't done this question yet, and take a look at it and see if you come up with the same answer afterwards. So pause the video for a second, and then you could come back to it. Otherwise, the best thing to do is when you see them like this, and this, by the way, is called a condensed structural formula, because it still shows you the structure, but the structure is condensed. What we're going to do is we're actually going to draw out the real structural formula for it. So all I've done so far is just draw out the hydrogens that are attached so that you can see that this CH3 here is this one that's here. This CH here is this one that's here. This CH here is this one that's here. This CH2 is double bonded attached here, right? Just check and make sure that all the carbons have 4 bonds. So this one does, right? This one does. This one actually does already too. So that means that the only place that the bromine can actually attach is right here. So therefore, the number that this would get would be, first off, that it's 4 carbon chain, so it would be called butane normally, but because it has a double bond, we have to say that it's butene. It would have the number 1 on it because it's at the first carbon, so that the lowest bond, or the double bond, has the lowest number. And then it would be 3 bromo. So 3 bromo, 1 butene. Okay, next question is this one. So see if you can do this one. Again, you might want to pause the video if you have to and then figure it out. This is a 3, by the way. Okay, this is another way to write a condensed structural formula. So this is another way to write a condensed structural formula. It still shows the structure, except it's kind of shortened here. So instead of writing it like this, they write it like this. Okay, the other thing is if maybe you have to draw out the real structural formula for it, so showing each line and each bond and each atom, so it looks like that. But you'll see that this is butane then. Okay, and then next, this one, how many hydrogens do you need to complete this? So this is question number 3. So how many hydrogens do you need to complete this? So remember that you do have that reference sheet for you to use when you're first starting off in case that you don't know things like oxygen takes 2 bonds, nitrogen takes 3 bonds, carbon takes 4 bonds, right? But you have to remember all those things. Bromine only takes 1 bond, for instance. Oxygen only takes 1 bond, those kinds of things. So you have to draw these on. So I'm going to draw a hydrogen here because that makes 3 bonds so far. I'm going to draw a hydrogen here because now this carbon has 4 bonds, right? The next carbon has 1, 2, 3 bonds, so I'm going to have to draw another hydrogen here so that it has 4 bonds. This carbon also needs 3 extra bonds, so 3 hydrogens, so that it has 4 bonds. And this nitrogen, so nitrogen has 3 bonds, so you have to draw another hydrogen onto it. So if I count how many hydrogens this molecule has, it has 1, 2, 3, 4, 5, 6, 7. So it has 7 carbons in total. Next, so you might want to pause the video again and see if you can name this one. So first, make sure that you find the parent. In this case, there is a double bond, so make sure that the parent includes the double bond, right? So don't think that the parent could be this, even if this happens to be longer or the same length, right? The parent has to include the double bond, and it also has to include the bromine. So it has to include the bromine and it has to include this double bond. So this has to be the parent here. So 1, 2, 3, 4, 5, 6, 6 long, so that is hexene. It's at the first carbon, so that would be number 1. This group here is called bromo. This group here that's attached is called propyl. So this is a propyl. So alphabetically wise, bromo comes first. So we write bromo. The bromo would get the number 6. And then propyl would be here. Propyl is going to get the numbers. So this is 1, this is 2, this is 3, this is 4. So it's going to get the number 4 bromo. Or 4 propyl, sorry. So 6 bromo, 4 propyl, 1 hexene is the name of that one. Okay, this one is very much like the last one we just did. I just wanted to see whether or not you could recognize the special bonding. So things like methyl, ethyl, propyl, those are very simple ones, right? But sometimes they actually rearrange where carbons can actually get attached. So they're actually called different things. So this one, this is still the parent of it. So this is still called hexene. Excuse me. So it's still called hexene. Still going to have a number 1 for the double bond. This is still bromo. So it's going to get the number 6. This thing here, this has 3 carbons on it. So it looks a lot like a propyl, just like the last question that we did. The only difference is it's coming off the middle carbon in the propyl and not one of the end carbons or one of the beginning carbons. So that has a special name, and it's called isopropyl. You'll see that the special names for some of your alkyl groups that you can use are tert, butyl, isopropyl, ethyl, methyl, those kinds of things. So you want to make sure that you check all those out on that extra sheet there. So this one we call isopropyl. I don't know if you guys have ever looked at the bottle of rubbing alcohol if you have one at home, but rubbing alcohol is actually called isopropyl alcohol. And so that's actually the name of it. Lots of the stuff that you eat will have the word isopropyl before things. So this will get the number 4 isopropyl. So knowing that now and using your reference sheet, make sure that you can figure out which is the longest chain here and see if you can name it. And again, you can pause the video if you want to try it on your own first and then see if you can get it. But going this way is the longest possible chain. So if I count this, it's 1, 2, 3, 4, 5, 6, 7, 8, 9. So that would be nonane. And then we have to name the branches. So these 2 are called methyl. This one here, I actually missed writing a thing on it. So this is supposed to be there. So this one has 4 carbons on it, but it's coming off this middle carbon, right? Or attached to the middle carbon. This is actually called tert butyl. So this is called tert butyl. Sometimes they just write T-butyl. That means the same thing. But tert butyl. Tert actually stands for tertiary, which means like the 3rd degree structure of it. This thing here is what we just looked at in the previous example. So this is called isopropyl again. So it has 3 carbons, so it is a propyl group, but because it's coming off the middle carbon, we say that it's called isopropyl. So we have propyl, we have butyl, and methyl. Now the prefixes that we put in front of them to show that they're attached in different places, like this iso or this tert, don't count in our ABC kind of order of it. So butyl would be first because it starts with a B. So butyl would be first. So tert butyl would be first. So that we have the lowest possible numbering, we'd start from this end. So tert butyl would get the number 5. The next one that would come would be the methyl group. So there's 2 methyl groups, so that would be dimethyl. They would have the numbers 2, 3. And then next it would be the isopropyl. The isopropyl would get the number 4. Okay, so that's just a little bit harder one, just so that you know that it is expected of you, right? We have just started off nice and easy, and now we're getting to be a little bit more complicated. Okay, try naming this one, see if I can trick you. You might want to pause the video again to see whether or not it's right. And again, I'm missing a hydrogen here, so pause the video, see if you can name it. Now here I want to make sure that first off you find the parent and it includes this, but most people tend to look just like this and say, oh, that's the parent. But just because this carbon is drawn down here doesn't mean that it can't be part of the parent. And so you want to make sure that you find the longest possible chain. So there is no one methyl, one ethyl on a simple alkane or an alkene. That means that you're not counting far enough. So you should never have one methyl, one ethyl, or one propyl on things like alkenes, alkanes, and alkynes, because that means that you didn't count the longest possible chain. So this is the parent chain. So it's 1, 2, 3, 4, 5, 6 long, so it's actually called hexene, and it would be called 2-hexene. Okay, these are very common in organic chemistry too, is they'll give you the wrong name of something and say, why is this the wrong name? Or this is what the teacher came up with, or this is what the student came up with. What is incorrect about the naming of this molecule? And so the best thing to do is to draw out what it comes by what name. So see if you can draw out this 2-ethyl-4-tert-butyl pentane, and then see if it really should be called that, or maybe if it should be called something else. So if you want to pause the video first so that you have a chance to draw it out and you can check your work after, you should do that now, but otherwise I'm going to draw it out. So pentane is 5 long, so I draw 5 carbons. Tert-butyl means it has 4 carbons, and it's coming off the 4th one. So it comes off here. Instead of it being like a chain of butyl, so like 1, 2, 3, 4, like that, tert means, again, that it's, what it does instead is it comes off the center one. So it comes off of here. So that, yes, there is still 4 carbons, but now what's happened is that it looks like this. And then, so I got this part, that part. So now 2-ethyl. So ethyl will go up here, like so. And then this would be where all my hydrogens would be. Okay, so what is wrong with my name? So again, now if you didn't get the drawing right, you might want to pause it again and just check and make sure, and then check my drawing and see, should it actually be called 2-ethyl-4-tert-butyl pentane. When I look at this, I actually see that the longest parent chain is here. So 1, 2, 3, 4, 5, 6, 7 long. So 7 long, so it should be called actually heptane instead. And that means that these things, this one, this one, this one, and this one, are actually methyl groups. So it should be methyl. Because we have 4 of the methyl groups, it should be tetra. And I don't want to start numbering from here, so this is not my first and second and third, because the numbers will be too high, right? So I want to start numbering from here. So this is 1, this is 2, this is 3, this is 4, this is 5, this one's actually 6, and this one is 7. So I should have 2, 2, 3, 5, tetramethylheptane is the name of this particular molecule. Okay, so draw 7 isomers of C7H16, and these are structural isomers. So the easiest one to draw for this one is, this is actually the formula for heptane, right? So the easiest one to draw for this one is heptane. So 1, 2, 3, 4, 5, 6, 7. So it has 7 carbons and 16 hydrogens. So this one is called heptane. Now remember that what we mean by structural molecules is that they have the same molecular formula, so they have the same number of carbons and the same number of hydrogens, but they're arranged in a different way, so they're called something else. So for instance, I can make a 6 carbon chain 1, 2, 3, 4, 5, 6, and add a carbon up here instead. If you need to, you can go ahead and pause the video, count how many carbons are there. If I actually drew all the hydrogens on where I drew a line, how many hydrogens would there be? You should see that there's 7 carbons and 16 hydrogens. This one, though, is no longer called heptane, right? It's actually called 2-methyl hexane. So now your job is to come up with 5 more that have the same number of carbons and hydrogens, but different number of same number of carbons and hydrogen, but different molecular structure, and name them all. So we're going to do that. So the other way that I can draw it is by drawing out, we'll start with 5 carbons instead, and we'll add 1 up here and 1 down here. Make sure that you get into the habit of at least drawing the lines on. Remember that when you write a test, you're going to have to write in every single hydrogen, right, to show every single atom that's attached to it. If I count again, there's 7 carbons and 16 hydrogens. So this one here, 1, 2, 3, 4, 5, make sure 1, 2, 3, 4, 5. The longest possible chain is still 5, so that's called pentane. It would get the numbers 2, 4, dimethyl pentane is another name that we could have. So that is also a structural isomer. Okay, let's draw some more. I can take that hexane again, and I can put the methyl group in a different place now. I can put the methyl group here instead. And this one is called 3-methyl hexane, and it also has 7 hydrogens and 7 carbons and 16 hydrogens, and so therefore it is a structural isomer also. So now we have 4, and we needed to have, let's go back and look, 7 altogether. So we got 3 more to go. Lots of times people will do this one. So lots of times people will do this one, and they'll try to tell me that this is the parent and this is the chain, so it would be called ethyl pentane and 2-ethyl pentane. But if I actually look at this one, when I look for the longest chain, here is the longest chain. So here is the longest chain. So this is 1, 2, 3, 4, 5, 6. So it's actually 6 long. So this is hexane. This is actually at the 3rd carbon. So this is methyl hexane. So this, which I thought was 2-ethyl pentane, was actually this one I already just drew. So make sure that you really check your drawings to see whether or not they're actually different, because lots of times you mistake it. Make sure you're counting the longest possible chain every which way, because even sometimes we think we do it differently, but it's actually not different. Okay, so next we're going to try, let's try moving the carbons around on a pentane. Oops. Let's try this again. So let's draw a pentane and move the methyl groups around on it. So we did have 2, 4 up here, so let's move the methyl groups to, let's move one here and here. So this one would be called 2,2-dimethyl pentane. Okay, let's try some other ones. Okay, the other one that we could get is by moving the methyl groups around one more time. So if we move the methyl groups around one more time, so by doing pentane, so we had 2,2, we had 2,4, let's just make sure, yeah, 2,4, 2,2, could also have 2,3, so this would be 2,3 dimethyl pentane. You could also have 3,3 dimethyl pentane is another one. That's 7. A trickier one, so there's actually 9 that you can draw in total, but a trickier one, because we did 7, which is what the assignment would have asked for, but another one is a butyl. So it looks like this, and then it has 3 methyl groups attached. So one here, and one here. So this is 2, 2, 3 trimethyl butane. So that's 8. And the last one that we're missing. So the very last one that you could have possibly drawn, so number 9 is, we almost drew it the other time, but we drew a pentane like this, and then putting the ethyl group here instead. So this is pentane and ethyl, so that is 3 ethyl pentane is the last one. Okay, next we're just going to look at the form or the definitions that I think maybe you would not get. So that's the very first worksheet, right, is definitions. Most of the ones on the first page I think you should be able to get. Actually, all of them on the first page you should be able to get. One of the ones I don't think you might get is this one, empirical molecular formula. This is just the simplest whole number, not hashtag, but whole number ratio of atoms in a compound. So for example, the real molecular formula, so real molecular formula of hexane is C6H14, but its empirical molecular formula of hexane, so I really take these and divide them by 2, is C3H7. Another one that I like to use is this one, is formaldehyde. Formaldehyde is actually this, is its empirical molecular formula. Formaldehyde is actually this, C2H4O2, so this is its molecular. Notice that to get the empirical molecular formula, all I did was take all of these numbers here and divide them by 2. But notice that glucose is this. Notice if I divide all of these by 6, so divide them all by 6, to get the simplest ratio, right? That's why I'm dividing them by 6 and not just simply 2. Notice that I get actually the same empirical molecular formula. So I get the same empirical molecular formula for glucose as I do for formaldehyde. Okay, the next one is expanded molecular formula. So expanded molecular formula is an expression which states the number and type of atoms present. So example is hexane. You just say C6H14. Sometimes expanded molecular formula, we just say molecular formula also instead of expanded molecular formula. Next is a structural formula. So when you do a test or a quiz for me, I ask you to draw the structural formula for it, showing me every single atom. So it shows the arrangement of atoms whether they are bonded to other atoms, whether it's single or double bonds, or maybe even triple bonds. But it shows every atom. So for instance, if we're using pentane, this is the structural formula for pentane, right? It shows every single carbon, every single hydrogen. The next one is what we call a condensed structural formula. A condensed structural formula is a shortened version of the structural formula. So for instance, with pentane, I would draw pentane like this. So 1, 2, 3, 4, 5. So just to make sure it has 5. Right, so this is pentane. The other way to draw this and also consider condensed structural formula is to do this. So rather than writing out CH2 3 times here, you just write it out once. Put the brackets around it, put a 3 here. The 3 tells you that it happened 3 times, and then end CH3. So this is also pentane. So that's a condensed structural formula. The last thing that I think you might not get is aliphatic. It's a compound containing carbon and hydrogen joined together in straight chains. Sometimes they're branched chains, so like a ethyl or a methyl kind of thing. So example would be pentane. Okay, so that should be it for the definitions. You should be able to get the rest of them from your textbook and from your class notes or your lecture notes. Otherwise, if you have questions, make sure that you email me.